Hi, I'm Angie, and I love Java. I teach free courses at Test Automation University, including a core Java programming course, Selenium WebDriver with Java, visual testing with Java, and a couple of others as well. While Java is still the leading programming language, it's gotten a bad rep over the years. So some of the biggest gripes I've heard are things like Java is too verbose, meaning we have to write a lot of code to do the most basic things. And also that the language was not evolving fast enough. So the releases of Java 7, 8, and 9 were all 3 years apart, which is almost a lifetime in software development. The powers that be have heard you loud and clear, and Java has gotten a much needed makeover. And now new versions of the language are being released every 6 months. And with so many new features, it may be hard to keep up. So in this talk, I want to demonstrate some of the newer features of Java and how we can take advantage of them in writing our code. We're going to look at some automation code for verifying this banking page. And the specific test we'll go over today is just going to make sure that all of the accounts are listed. So here's our test code, and let me walk you through it. Here we are logging into the application and we get a handle to this accounts overview page. And this is where that table of contents is located. Next, we get a list of the account numbers that are displayed on the page. Then we want to get the expected accounts. So this test data can change. So we actually are going to make a call to an API to get the expected accounts. And this returns a list of deserialized account objects. So we want to make a new list which will only contain the account numbers as strings as opposed to the entire account. We loop through the list of account objects and add the account number from each account into our list of expected accounts. Finally, we compare both lists to make sure that every account for this customer is actually shown on the site. So this test was written in Java 8. And we're going to go through it and see how we can modernize it using some of the latest features in Java. So let's start here with the declaration of the accounts overview page. As you can see, we're following Java conventions and we're using good names for both our class and our object. However, many times, as we see here, these two names are the same thing. So this is redundant and it makes for a lot of typing. So in version 10, Java introduced type inference for local variables. And what this means is that instead of explicitly declaring the object or variable's type, we can instead use this keyword var, and Java will infer what the type is based on what is being assigned to it. This is my favorite new feature in Java because in test code, we always have these long class names for our page models, and now we no longer need to type them out. Now, before you get carried away and start using var everywhere, let me explain the rules and also give a couple of tips. This does not make Java a dynamically typed language like JavaScript or Python. The type is still there, it's just inferred from the right-hand side of the statement, which means you can only use var if you're actually initializing the variable. Otherwise, Java is not going to be able to infer what its type is. Also, it only works for local variables. You can use this inside of methods, loops, decision structures, but you cannot use this for global variables, even if you are initializing them. While local variable type inference can be used within the body of local constructs, it can't be used in the headers of methods or constructors. And this is because whoever's calling you needs to know the data type of the arguments that they need to send. Okay, so those are the rules. Now let's get into some guidelines. Given this variable name and this method name, I have no idea what the inferred data type of X would be. Sure, Java will know because it knows what getX returns, and so it's able to tell, but me as the reader, I can't easily tell what this is. So this makes it really difficult to work with this variable. You should always use good variable names, but it's even more important if you're going to use var. Now, once you start using this, you're going to love it. But please, please, please don't overdo it. So using var here, it doesn't do you any favors, right? I mean, var is 3 letters, int is 3 letters. It didn't save you any typing or anything, right? So don't do this just for the sake of doing it. Just type in int. So I've updated our test method to use var. So I'm using var here, and the inferred type is very clear to me as the reader because of the variable name I chose. Here, I changed the variable name from actual accounts to actual accounts IDs list so that it's clear this is a list and it's holding the account IDs. For this one, I also changed the name from accounts to accounts list so that it's clear this is a list holding account objects. Here I changed the name to be more representative, and I also explicitly defined the data type of the array list on the right hand side. If I didn't use this diamond operator to indicate that this is a list of strings, then it would be inferred as a list of objects, which is okay in this case, but this could get you into some trouble down the road. For example, if I wanted to use any of the elements from this list, which are technically strings, and I wanted to do a dot and maybe use one of the methods from the string class, I wouldn't be able to do that because Java has inferred it as an object. So it's safer to go ahead and explicitly specify it using the diamond operator. And then here, I'm using var inside of a for loop just to show you it can be done here as well. Okay, let's see what else we can modernize. How about we look inside of this getAccounts method? Remember, this is the table and we're getting all of those values in the first column labeled accounts. Here's the code to do so. We see here it finds all of the account sales and these are web elements. Then it creates a new list to hold just the text of the web elements. So this is a list of strings. To populate that list, we loop through each of the elements from line 3, get their text, and then add them to our new list from line 6. And notice this method needs 2 lists and a for loop. So there's a more modern approach to do this in Java by using the functional programming style. This approach was actually added in Java 8, but I don't see it used much in test code, so I wanted to highlight it briefly. This is much more streamlined. Here we can still call find elements to get the list of web elements, but we don't need to store them. Instead, we turn them into a stream from which we can do some cool functional programming. So this map function will take those web elements and then map them into whatever is passed into this. So here we're saying get the text from these web elements and then store them into a list which we return. Here's an alternative way to write the map call. Notice in the top example, line 5 uses a shortcut or syntactic sugar, but in the bottom example, line 3 uses the fully spelled out approach. We can do the same in our test method. So instead of using the 2 list in a for loop, I use a stream and map what I need into a single list. It's a good practice to break up these chained method calls where each method call is on a new line. It's really tempting to do this big, powerful call all on one line because it's like, wow, look at this wicked one-liner. But it makes it harder to read your code and process what it's actually doing. So it's a good practice to break it up so that each call is on a new line. Okay, let's look at what's new with streams. Java 9 introduces a couple of new methods to stream, one being takeWhile. Let's say I have this code, which gets the list of accounts, and then uses the takeWhile method on this stream of accounts. Within the takeWhile method, you pass in a condition, also known as a predicate. And this is saying to go through this list of accounts and accept all of the ones that have a type of checking until you get to the one that does not have this type. So here are all of the accounts stored in the accounts list. And notice there are 11 of them. And when we say takeWhile type is checking, we end up with a list of 3 accounts. And as you can see, it's the first 3 accounts from the accounts list. But when it got to the 4th account, the type was savings. So the stream is ended. Java 9 also introduced dropWhile, which does the opposite of takeWhile. for this one, we're saying drop the accounts of type checking until you get to one that's not. So with 11 accounts here, we see the first 3 are checking, the 4th is savings, the 5th through 9th are checking, the 10th one is savings, and then the last one is checking. So how many accounts do you think will be collected here in checking accounts list? If you said 8, you are correct. This method dropped the first 3 accounts because they matched the predicate, and then it stopped the stream. So all other accounts are collected and stored into the list. And all of the accounts couldn't fit on the last slide, so here's the full list of dropWhile account type is checking. So you might be thinking, why on earth would I want to use takeWhile or dropWhile? Well, the examples I showed you were a bit of a brain tease because the lists weren't sorted, so the results were indeterministic. However, if you sort the collection first, as we're doing here, it makes a lot more sense. And notice I'm using this comparator to specify which property I want this object sorted by. Given the sorted list, we see it collects all of the checking accounts, and this actually makes more sense. Likewise for dropWhile. Okay, let's see what else we can modernize. Let's take a look inside of this get customer ID method. So this method is holding our test data, and based on the name on the account, it's returning the account ID. This is using the switch statement, and notice we have to declare the variable and then specify each case we want to handle. Inside of the case, we can assign the value to ID, and then we must follow the assignment by a break statement to prevent fall through into the next case, which would override the variable. Not only is this a lot of boilerplate code, but it's also risky. If you forget one of those break statements, then you'll return the wrong ID. In Java 12, switch expressions were introduced. Now you can use switch to directly assign a value to a variable. Notice here we're using switch on the right side of a statement to initialize this variable. The case statement doesn't need a colon in switch expressions, but instead uses an arrow. And this is saying if the name is John, then assign 12212 to the variable ID. Notice that I don't need a break statement because there is no fall through with switch expressions. I can even simplify this a bit more by removing the assignment here and just returning the result of the switch expression. Now, using the lambda style arrows is one way to assign the value, but you can use another approach. You can use the colon that we're used to, but you need to follow it with the word yield. So a bit more verbose, so I actually prefer to use the arrow. You can also specify more than one case. Notice here we're saying if the customer name is John or Demo, which is his last name, then the ID is 12212. So this makes up for the removal of fall through from switch expressions because you can indicate all cases delimited by a comma. You can also do more than just assign values. For example, here we're using the lambda style arrow followed by a set of curly braces to indicate we want to do more here. And inside of the body of this case, we can add more statements like this one. But the last line of the case must yield a value to be returned. Okay, let's talk about rules. So you'll need to use the arrows or the colon yield. You can't use both. So line 3 would give you a compilation error because it's a different kind of case. You can use yield with the arrows, but only in events like the last case where you're using the curly braces to execute multiple statements within a case. You can use any of the cases to throw an exception. So of course, in this case, no value is being returned for ID. You can use any of the cases to throw an exception. So of course, in this case, no value is being returned for ID, and instead the entire flow is interrupted by the exception. Now, I'm showing this throwing of exception in the default case, but this could be any of those cases. So I could say if the case is Mary, throw an exception, or if the case is default, throw an exception. So it can be any of these. This is not a replacement of the switch statement. It's an addition to the language, meaning you can still use switch statements, and in some cases, that might be the more favorable option. As a rule of thumb, use expressions when you are using the switch to assign a value, and use statements when you're not using the switch to assign, but you're using it to actually invoke statements. Okay, back to our test. So let's go to this getAccounts method, which is making an API call. So this method is making a get call to get all of the accounts for the specified customer. It's then deserializing the response into an array of account objects. Let's look at the API response for this call. Notice here, we have an array of these account objects. Each account has an ID, customer ID, type, and balance. So I have this Pojo class that has nothing but these fields, as well as getters and setters. For any of you who have created Pojos, which are plain old Java objects, meaning just some fields, and then the getters and setters. For any of you who've created these, you know that this is tedious to do. And many people have moved to using the Lombok external library so that they don't have to write all of this. But in Java 14, a new construct has been introduced called records. This is a record. Much shorter, right? Notice here, instead of using the word class, we use the word record. Also, as opposed to opening this with a curly brace, we use parentheses to declare the fields. You specify the fields and their data types in this comma delimited list, and then you close it with a closing paren and curly braces. And that's it. You don't need to make any getters or setters. You don't need to override the inherited methods such as equals hash code or toString. It's all just there and done for you. However, if you just want to override anything, you can do so within the curly braces of the record. Records can be instantiated just like classes. Account is the name of our record, and we use the new keyword to call the constructor, passing in all of the values. The fields of record are final, so there are no set methods generated for records. Of course, you can add a setter within the curly braces of the record, but I don't really see a good reason to do that since the fields are final and can't be modified anyway. You do have accessor methods, however, they don't start with the word get. Instead, the accessor method name is the same as the field name. So notice the account.balance call here as opposed to account.getBalance. Records were released as a preview feature in Java 14. Which was released in March. And what this means is that it's not yet a permanent feature of the language. It's just available for us developers to play around with and offer feedback. And based on that feedback, the implementation can change. So don't use these in production code just yet. It also means that support from external libraries may not be available just yet. For example, the Jackson library is used to deserialize that JSON response into this record. However, the Jackson library doesn't officially support records yet. So as a hack, you'll need to explicitly bind each field to its respective JSON property. And when and if records becomes permanent, I'm sure Jackson will provide support so that the explicit binding is not necessary. Next, I want to show you text blocks. So let's continue on with the API. What if instead of calling the API, we instead wanted to mock the data right there in the API util class? To represent this whole thing as a string would be very tedious. We need to escape all of the fields because they were already in quotation marks, and we need to add new line characters for each line break, and we need to add the plus signs for each new line. So this is ugly to read and ugly to write. Text blocks allow you to use 3 quotation marks to open and close a big block of text. So notice you don't need to escape anything. The individual quotation marks are still there on the fields and the line breaks are respected. Text blocks were introduced in Java 13 as a preview feature, and we got a second preview in the latest release, Java 14. So this is also not a permanent feature just yet, but it is slated to become permanent in the next release of Java, which is in September. All right, let's look at some rules and guidelines. You cannot include the entire text block on the same line. You'll get a compilation error if you do this. A new line must be after the opening quotes, like in the second example here. This is legal, but not the preferred way, right? Doesn't look that great. The preferred way is to have both the opening and the closing quotes aligned and on their own individual lines. Okay, one more thing I want to show you in that API class. Let's say we didn't want the entire response, but we wanted to just return a hard-coded list of expected account IDs. The old way of doing this would be to use the arrays.addList method. However, in Java 9, this of method was introduced for all entities in the collection framework. So lists, maps, sets, etc. This one seems small, but I've actually been enjoying it. I think the reason is that it's more natural for me. Before, it took a cognitive effort to recall which class do I use to make a quick list, Is it array? Is it arrays? Plural? What is it? But now, I want a list, I call list.of. I want a map, I call map.of. Nice and straightforward. Speaking of maps, populating these required a separate method call for each item that we wanted to add to the collection. Now you can define a map all with one line of code. The parameters are key followed by value. And you see here we have 3 entries in this one line. One thing to note about using the of method is that it creates collections which are immutable. And what this means is that the collection cannot be changed by adding, removing, or sorting it later. So only use this when your collection won't require any changes later on in the program. So there you have it. These are a few of my favorite new features from recent versions of Java. I've been using them in different projects and I find them quite useful even for test code. Thank you so much.